All right, so what we have is we have an iron nail and we have copper 2 chloride. This is the demonstration for the small scale chemical reactions lab. What we are going to do is we're going to do a single placement reaction of the iron in the copper 2 chloride. We have a control of the iron 2, or excuse me, the copper 2 chloride. Then we have a control of the iron. What I'm going to do is I'm going to put enough of the copper 2 chloride in this test tube to completely submerge the nail. Why would I do that? Jake?
So the entire nail submerged, the entire nail experiences a reaction.
And why does it have to be completely submerged for that? What am I looking for? No, what's the reason for entire submersion?
That everything happens
Everything happens where?
on the nail.
On the nail.
In the tube. So it's an enclosed reaction.
You guys are right on it, but you're missing the two most important words about it. Everything happens at the
Same time.
not same time. You have the first letter right. This class is, you guys are like right there. You're making me snicker a little bit, but you're still just a little bit off. Why do I want the nail to be completely submerged? What is completely covered if it's completely submerged? The nail is completely covered. So what?
The copper chloride. Yeah.
Where does all reactions occur at?
The whole nail.
Okay. All reactions occur at the surface area. So if it's completely submerged, the entire surface area is in contact with the solution. More of the surface area will be able to react. That's the purpose of it. So this has got enough to be completely submerged. I'm going to put the nail into it. It's completely submerged. You can tell right away what happened to the color of the nail. It got black right away. What else happened to it? Anybody notice anything about the nail?
It looks bigger.
It looks bigger. Why does it look bigger all of a sudden? Go ahead. It's actually not that. A lot of people think it's because the water distorts it, but in this case, it's not enough. It's not enough to distort it. How about if I do this? You guys see what happened there?
Oh, the iron was like it was.
It wasn't the iron coming apart, actually. The iron dissolved. The iron went away. But something else happened that made it look bigger than it actually was. Mary, what do you think?
The copper chloride.
You just stay with the first word.
The copper.
The copper did what?
Oxidized it.
Not oxidized. Go ahead. The copper was being replaced by the iron. So when the iron replaced the copper just hung out on top of the iron. So when I hit it, the copper comes off, it just breaks off of the surface of that iron. It does a couple things. Number one, it falls off. It's what makes it look a little darker. Two, it clears off that surface area, so it cleans it off, so that solution has contact with clean surface of iron, so that reacts it really fast again. It actually is if we were to still teach reaction rates, agitation is actually something that you can use to speed up a reaction, because anytime I can flush the surface area with a clean solvent, I'm actually causing the reaction rate to increase. By removing the product from the surface area and flushing clean solvent over the surface area, the reaction will occur faster. So anytime I agitate this and knock some of that product off, I'm going to bring some of that the solvent off, or the solvent over the metal. It'll cause it to react faster again. So every time I do that, it's going to get darker and it's going to have more of the copper fall off of it. So over time, you guys are going to come and check this out for a couple more times. So let me check this out. This is to compare it against last hour. You guys see the difference? Okay. This one is third hours. All right, here's second hours. You guys seeing the difference there? And then here's first hours. No rust at all. There is no rust at all in this. So over time. All right. So as you guys go through the rest of this period, 2 more times, you're going to check it against, you're going to go check this, you're going to take some pictures, add it on. What's happening? It's proving that this iron is replacing the copper in this compound. That's what you're trying to do. What do you see that's proving to you that the iron is replacing the copper in this compound that's making this single replacement reaction occur?